Welcome to the Easy Math Guide. Today I'm going to be briefly going over 6 theorems that may or may not help you prove a triangle's congruence or similarity. First up, we've got SSA. This is your side-angle side theorem, and it doesn't show congruence. So you can see from this picture here, I drew 2 pairs of legs that are the exact same length, and you've got one angle pair that's the same measure. Now this theorem doesn't tell us what the other leg and those 2 angles have to be, so I made D really big, and I made that segment from E to F really small. And you can see we've got this gap, so that triangle to the right, well, it's not even a triangle. So you can't always rely on this theorem alone to prove congruence, but you can pair it with another one. Next up, we have SAS. This is your side-angle side theorem, and this one actually works. So we've got 2 pairs of matching legs, and we've got this matching included angle right here. Okay, now for a visual, I like to extend my sides out because I know if that middle angle, that included angle right there, if they're the same length, they're going to open up and it's going to kind of connect those really long dots in the same exact place. So those 2 that I just highlighted are going to be the exact same length no matter what. So this one's always going to work. Another way to look at this theorem is that if those angles were to be the same measure, those matching legs will still be the same exact length because they've got to open up the same amount. Next up, we have this angle side theorem. So now recall that triangles add up to 180 degrees, right? So if 2 of our 3 angles are the exact same measure, then that third one's also going to be that exact same measure because again, 180. And then this one side length that we know prevents the situation up above because all those other legs are going to have to be the same too. And we can use the same exact logic on ASA, this angle side angle theorem, because again, we know 2 angles and we have a side, so they add up to 180 and they prevent that situation up above. Angle. This one shows that our triangles are similar. They're the same shape, they're not the same size. So you can see I drew 2 triangles. They've got all matching angles, but they've got some funky side lengths and they're not the exact same. Because you can draw one picture really, really big, you can draw one really, really small. It just kind of depends on the scale that you're working with. And then finally, we've got our hypotenuse leg over here. This one's only for your right triangles, okay? So we have our 90-degree angle, and we've got our 2 matching sides again, and I'm going to use the exact same logic we just did. So if our angles are opening up the exact same amount, then our legs are going to be the exact same length. So if they opened up bigger, the sides would be longer. If they open up less, they'd be shorter, yada, yada, yada. So again, because they're the same length, we've got to assume they've got the same angle measure and open up the same exact amount. Alright, that was a super brief overview of these theorems. If you need me to do any deep dives into specific ones, let me know. And if you want to see specific examples, let me know. And comment what you need help on. I'll see you next time.